Hello and welcome to Today I Learned Climate, MIT's climate change podcast. I'm Laur Hesse. And today we're talking about storing carbon dioxide underground, which is something that companies are doing right now, today, to the tune of tens of millions of tons a year. Why? Well, if we put CO2 into the atmosphere, say by burning coal, oil, and gas, it heats up our planet. So people have come up with ways to capture this CO2 from the smokestacks and exhaust streams of coal, gas, and industrial plants so that it can't escape into the atmosphere. There's even technology that can pull CO2 out of the air around us, something that folks call direct air capture. Whether pulling it from a smokestack or from the air, companies compress that CO2 into a fluid, pump it underground, and voila, it can't contribute to climate change. If you're interested in how these technologies work and their benefits and challenges, you can check out our 2 episodes, TIL about carbon capture and TIL about removing CO2 from the atmosphere. But now you might be wondering, what happens to this liquefied CO2 under our feet? Is it dangerous? You might ask us, as Barbara Ann W. of North Carolina did, could pumping CO2 underground cause earthquakes or contaminate drinking water? Or you might, like Christopher B. of the United Kingdom, ask us, is there a risk that CO2 stored underground will escape? Today, we're answering these questions with help from Professor Brad Hager. He's a geophysicist and associate director of MIT's Earth Resources Laboratory.
We actually have a lot of experience with fluids under pressure underground. Oil and natural gas themselves are trapped in the subsurface for millions of years until someone comes along and drills a hole and lets them out. So because of the oil and gas industry, we know a lot about conditions under which fluids are trapped stably underground.
One way to think about carbon storage is that it's returning carbon to where we got it. The carbon was part of oil and gas snug below the earth. We drilled it out and burned it to make energy, and now we're collecting it and pumping it down there again as liquid CO2. Still, you can't just drill a hole anywhere you'd like and start pumping CO2 into it. That really could cause leaks and earthquakes.
The big thing which determines whether injecting fluids causes earthquakes is basically the geology that you're injecting into. You do not want to inject into an area that has active faults, and you don't want to inject into an area that has brittle rocks.
If you inject any kind of fluid underground, it's going to raise the pressure in the surrounding rocks. And if you're injecting near a fault line, which are areas more susceptible to earthquakes, that pressure might actually slide the earth on top of it around. It's kind of like turning on an air hockey table. You add some pressure coming up from below, which moves around the puck.
If the local rocks are brittle, like say sandstone or granite, they're also more likely to crack. And just like injecting near a fault line, that could trigger an earthquake. And it could let the carbon dioxide leak back out.
That hasn't been documented at any CO2 storage sites, but wastewater has leaked when oil and gas companies pump this wastewater underground, so we know it's a real risk. What you want, ideally, is some sort of underground formation that has room to take in a bunch of fluid without moving or cracking. Rocks like sandstone and limestone are porous. If you inject CO2 into these, it can seep into the pores of these stones and stay there, kind of like water seeping into sand. But you don't want the whole formation to be porous.
You also want a cap rock, a hard layer on top that seals in the CO2. The cap rock should be solid, but a little malleable. Shale is often a good candidate. And finally, you want to inject the CO2 quite deep, at least 3,000 feet. That will keep it at a high pressure, so it remains a dense fluid and doesn't turn back into a gas. It's also deeper than the aquifers that we use for drinking water.
Put it all together, and that's an awfully specific list of requirements. You might be wondering, how do we even find these places?
It requires a lot of study, but with fairly standard techniques that the oil and gas industry uses all the time, you'd start with seismic reflection studies to characterize the structures.
That means that geologists make a vibration at the Earth's surface using something like an air gun or a piston that hits the ground really fast. That creates a seismic wave that travels underground and then reflects back up. And with special equipment, we can listen for what kinds of rocks are underground.
And if that looks promising, you drill some test holes to get some ground truth on those seismic images, so you can actually sample the rocks that are there and understand things like their porosity, their permeability, how easy or difficult it is for fluids to flow through them. And there are a lot of places in the world where this seismic exploration and drilling has already been done in the search for oil.
Yeah, it turns out that oil and gas tend to be found in the same kinds of malleable rocks that are good for storing CO2. Sometimes we can just turn around and use those same places for storage. In fact, the most common way that companies store captured CO2 today is by pumping it into active oil wells to help flush more oil out. This is something called enhanced oil recovery. And to be clear, it's not a long-term climate solution because it's used to help push out more oil that's going to be burned and put more climate pollution into the air. But geologists have also scouted out a lot of formations that could be used for CO2 storage without the oil production.
For instance, the Gulf of Mexico is an area which is very conducive to carbon storage. But there's been a lot of extraction activity already in the Gulf, so one would have to be careful not to inject fluids near abandoned wells where the CO2 might leak back out. You want to make sure that you're not in an area which had been turned into Swiss cheese by previous drilling operations.
Now, I mentioned at the beginning of this episode that carbon storage is already going on. So another question we can ask is, have we caused any leaks or earthquakes?
It depends. So there's a place in the North Sea called Sleipner, where CO2 injection has been going on for about 30 years, since the mid-1990s, at a rate of 1 million tons a year. And the layer that they're injecting into is so porous and so permeable that they don't even have to pump the fluid in. It basically runs in under its own weight. It's been a real success story. But then there was a site in Algeria, for example, where they were injecting carbon dioxide, but the rocks were very tight. They had difficulty getting the CO2 in, and there was evidence that they actually started to fracture the rock. The cap rock was very thick, so the CO2 didn't end up leaking, but they did have to halt storage.
So far, there haven't been any CO2 storage disasters. That's great news, and a sign that this is a plausible climate solution. But the failed project in Algeria does underscore how important it is to have responsible management of these storage sites, to monitor them, and to make adjustments once they get going. And, unfortunately, there are companies that have not always been careful about the environmental risks like these. For instance, we could look to something that humans pump underground today in much greater quantities than CO2, wastewater.
In a lot of places where oil is produced, water is mixed in along with the oil. So the oil that's coming out is not pure. And sometimes, like in Oklahoma, they're getting 10 times as much water out as they're getting oil. So the usual way of disposing of this wastewater is to drill a hole in the ground and inject it back underground. Right now, there are hundreds of billions of gallons of wastewater injected every year.
So if we're worried about causing earthquakes when we pump carbon underground, a good first question to ask might be, are we causing earthquakes now when we dispose all of this wastewater underground?
Earthquakes can be a big problem, but they're a tractable problem. Most wastewater is injected without causing any earthquakes at all. There are places like Saudi Arabia, for example, where a lot of wastewater is injected and earthquakes are not resulting. But then there are places like Oklahoma, where injecting this wastewater has led to earthquakes.
Yeah, Oklahoma saw a surge of earthquakes in the 2010s alongside a boom in the local oil and gas industry.
We knew that earthquakes were happening in Oklahoma before people began drilling for oil and gas and pumping wastewater back in. So it was known to be an area of seismic risk. And unfortunately, some companies in Oklahoma were not very careful about where they injected the wastewater.
These kinds of events are preventable, but they do have to be prevented. And that means when there's a proposed carbon storage project under evaluation, it's not just the geology we have to ask questions about. We also need to ask the kinds of questions that we would pose for any big infrastructure project that might impact the environment. Like, does the company have a good track record? What regulations are in place and are they well enforced? Can we get a third party to evaluate the safety risks?
It's basically a management question of carrying out the storage responsibly. And I want to be clear that there are risks, but there are risks to everything. And the risks for continuing to emit carbon dioxide into the atmosphere without taking it out far outweigh the risks of putting the CO2 underground.
That's it for our episode today. Do you have a question about climate change? Maybe we answered it as part of our Ask MIT Climate series. You can find out at tilclimate.mit.edu. And if we haven't, ask us. Leave us a voicemail at 617-253-3566 or visit climate.mit.edu/ask. We release answers as episodes here on TIO Climate as well as on the website. I gotta say, we love hearing from our listeners. It totally lights up our day. We would love to hear from you too. Let us know who you are and what you're working on or what you're wondering about and why you're listening to the show. Send us an email at climate@mit.edu. TIO Climate is a climate change podcast of the Massachusetts Institute of Technology. Aaron Krol is our writer and producer. David Lishansky is our sound editor and producer. Michelle Harris is our fact checker. Sylvia Scharf is our climate education specialist. The music is by Blue Dot Sessions, and I'm your host and executive producer, Laur Hesse Fisher. Thank you, Professor Brad Hager, for speaking with us, to Barbara Ann and Christopher for your questions, to Lindsay Fendt for the original reporting used in this episode, and to you, our listeners. Thank you for your climate curiosity.